which are taught again and again, so that you don't have to face any problem when you come again, hopefully in the month of June. Okay. So let's continue with our topic, that is heat, chapter 4, and here we were discussing about what actually heat is. I taught you in the class the various ways in which the temperature is measured, the various scales in which the temperature is measured, and we know that what are the 3 scales of temperature. Let us quickly revise. What are they? They are Celsius scale, Fahrenheit scale, and Kelvin scale. And Kelvin scale is the SI unit for measuring temperature. Okay. Now we will speak about the transmission of heat. So in our previous video, I taught you about the instruments that are used to measure the temperature. So those are nothing but called as thermometers. Basically, there are 2 types of thermometers, the clinical thermometer and the laboratory thermometer. I gave you some material. I hope that you followed it, you have written down in your running notes and learned it. Please do understand before actually learning it. First understand, and in case you get any doubt, please do ask me. After that, you try and write in your own words. Okay. So I gave you the differences also, each separately, the features of clinical thermometer and laboratory thermometer, also the differences between the 2 of the thermometers, right? So today we will just go step ahead and we will learn about the transmission of heat, how the heat is actually able to flow. It's nothing but the movement or the flow of heat from one place to the other, one object to the other. How is it done? Let's compare the flow of heat with other things, like say for example wind. How does wind blow? Wind blows from a high pressure region to a region which has low pressure. So it blows from a region where the pressure is high, atmospheric pressure, and to the region which is low, having low pressure. In the similar manner, if I put a drop of water on my hand like this, what will happen? Where will it flow? It depends on the level. If I put it like this side is higher level and this side is lower level, and the water, in which direction will it flow? Will it flow from here to here or from here to there like this? No, it flows down. So always water flows from a higher level to a lower level. In the similar manner, we have heat flowing from a body having higher temperature to lower temperature. Always remember, heat always flows from higher temperature to lower temperature. If any substance has higher temperature and any other substance is lower temperature, the heat will flow from higher temperature body to the lower temperature body. Or in simple words, I can say from a hotter body to a colder body. Did you understand? And how long will it continue to flow? Until they both reach equilibrium. That is, one body is very hot and the other one is very comparatively colder. Then what will happen? The heat will continue to flow from this body to this body until both of their temperatures become equal. And when their temperatures become equal, there will be no flow of heat between them, because both of them have got into equilibrium, children. Did you understand? So that's what. If I put a drop of water here, if the level is same, will it move? Which direction will it move? It won't move because the levels are same. In the similar manner. Hope it is very clear, children. The heat flows from a hotter body to a colder body. So today I will just teaching you about conduction, children. What is conduction? You just remember that always it happens in solids. This is a mode of transmission of heat which occurs in solids, children. In solids, the heat flow takes place through conduction. It is called as conduction. Now let us go into the molecular arrangements of solids. How are molecules arranged in solids? You tell me. The molecules are arranged very tightly and they are packed, isn't it? There is no space. We have learned this in our lower classes, right? If you will consider this as the molecules, you can see that the molecules are very tightly packed. They are very compact. molecules won't move. So how is this heat energy now transmitting, or how will it transfer from one place to the other? Imagine you just put a pan on the stove. So now the stove, when you just lit the stove, what will happen? You will see that the flames come, and that is the source of heat now. That fire is the source of heat. It is hotter naturally. When you put the pan on top of it, now what happens? The pan gets the heat energy from the flame and the pan gets hotter. Now you keep a spoon on the pan. Now what is happening? A pan is now the solid and spoon is also solid. Now you just keep it on top of the pan and you will see that, the end that is in contact with the pan will get hot first. Like this. Take a pan. Okay. Now, on top of this, you just keep a spoon like this. A spoon. Okay. You keep a spoon like this. A long handled spoon you keep. Now, you will see that this is already hot. The pan is already hot. And now I kept this spoon in such a manner that only the ladle or this head, the top portion, is in contact with the pan. Now this head, this will get hot first naturally because it is in contact with the hot pan. Now can you hold it after 5 minutes? Can you hold this end after 5 minutes? No, because the other end also will become hot. What happened here? The heat, it traveled from the portion which is in contact with the pan to the other end, isn't it? Even the handle also will become hot after some time. Immediately it may not become hot, but after some time the handle, or which is not in contact with the pan, also becomes hot. Yes or no? So why is it happening? How is it happening? How the heat energy from here is getting transmitted till the end of the spoon? That is through conduction, children. It is through conduction. You see that the spoon is a solid and it has molecules like this, one attached to the other, joined, isn't it? So now, if these molecules, for example, if they get hot, if they become hot, then what will happen? These molecules, they transfer the heat energy to the adjacent molecules. They need not move. It's simply like passing the pencil or the book or a chalk from one person to other without moving. What is happening here? Because these molecules, they don't have a chance to move around. So what do? They simply pass on the heat energy to the adjacent or nearby, attached just to the next molecules. And these get hot. Now what will happen? They will just transfer the heat to the other molecules. Like that, the process continues until it reaches the end. Did you understand? That's the reason why the heat energy from the head is transmitted till the end, and this point also becomes hot afterwards. Did you understand? It takes place only in solids only. And this type of or mode of transmission of heat, it's called as conduction, children. What is happening here? Please understand one thing. What is happening here? The heat energy is transmitted to the other molecules without the actual movement of the molecules. Are the molecules moving here? No. So the molecules do not move, but simply pass on to the next molecules, pass on the heat energy to the next molecules. They take it from the source and pass on to the next molecules. Is that clear, children? That's why it occurs, this kind of mode of heat transmission occurs only in solids where the molecules need not move. Okay, it happens without the actual movement of particles. That's why it's called as conduction, children. Now, there are so many applications of conduction. If you want to cook food, then that vessel or the utensil should get hot. Yes. So, what kind of material should we use for making cookers or any utensils for cooking food? We have to use those metals which those which are good conductors of heat we use for, the utensil itself, like where the food is, raw food is added and then we cook it. So the main body is made with the metal and the wooden the handles are usually made with non-conductors or poor conductors of heat such as wood or bakelite. Okay, so that's the reason why we use bakelite or wood for, or hard plastic for handles, children. Did you understand? Hope it's clear. I want you, today's homework is, I want you to find out many more applications, at least some 4 to 5 applications of conduction, children. I want you to just find out where good conductors and poor conductors are used. Okay, conduction in particular, applications of conduction, you need to just jot down some points in your running notes. Okay, thank you.